Calc AB, October 28th. Okay. There's no snow on Janet's driveway when snow starts to fall at midnight. From midnight to 9, the snow accumulates on the driveway at this rate. So this is a rate at this many cubic feet per hour, where the T's measured in hours since midnight. She starts removing snow at 6. The rate G of T in cubic feet per hour at which Janet removed snow from the driveway at T time hours after midnight is multiplied by this. Wow, so she, oh my gosh. Okay, so she, right, so she starts removing snow at 6 a.m. So until 6, she was sleeping. Until 6, she was sleeping. From 6 to 7 after she first woke up, she was just hauling. She was just getting rid of that. She's getting rid of that snow at a rate of 125 cubic feet per hour.
That's a lot.
That's a lot.
How big is her driveway?
How much is a cubic yard?
No, how much?
27. So she got rid of 5 cubic yards of snow.
Okay, how big is her driveway and how much snow?
And then from 7 a.m. to 9 a.m. she got a little tired, so she slowed down. She slowed down a little bit, okay?
She got tired.
Find the rate of change of the volume of snow in the driveway at 8 a.m., okay? All right, so the rate of change is going to be what? The rate of change, so let's say function. What's the rate of change function going to be? So the rate at which the volume volume of snow accumulates. Sorry, I didn't know it was lots. All right, it's going to be what? So it's going to be the rate at which the snow accumulates minus the rate at which Janet removes it, right? It's going to be, let's call it S prime of t. Let's call it S prime of t. It's going to equal the rate at which, so it's going to be f of t, the rate at which it accumulates, minus the rate at which it's removed. Does that make any sense? That's going to be 7t e to the cosine t, e to the cost, minus g of t. So it's actually going to be a piecewise itself. So you should do S prime of t equals, and then a piecewise. I know you've learned it the last 2 years. So from 0 to 6, it's going to be minus 0, or just itself, just f of t. From 6 to 7, it's going to be minus 125. From 7 to 9, it's going to be minus 108. Okay, are we confused? Are we following?
Can you talk to that?
Yeah. So between t equals 0 and t equals 6, right? The snow's accumulating at this rate. It's always accumulating at that rate. So we're adding that much, right? We're adding the rate of change. We're adding in that much snow, and we're not removing anything. Okay, that's between 0 and 6. We're doing minus 0, I guess. Okay, you see the first line? Second line, right? We're still adding in snow at the same rate, but we're removing it at a constant rate of 125 cubic feet per hour. That's between 6 and 7, when Janet first starts removing the snow. And then from 7 to 9, she just starts removing it a little slowly. Okay. That's your answer for A.
Still fast.
It's still very fast. You can't do that.
Not with that
She's on.
Have you graded
Is that
some
how
of
we
our
find the
tests?
Yeah, that's it. Yeah.
Have you graded some of our tests?
No, I'm waiting for everyone to finish taking it, which I think everyone has, and then I'm going to get the answer key and start. So try to do it over the weekend.
You
Got
probably
pretty-
use mine as
How do you think we've done
I don't know. All right, so can we do example 2, or any more questions over 1? Example 2, a penguin population gets modeled by a differentiable function p of time t. All right, this stuff's actually really applicable to the real world, where p of t represents the number of penguins. Okay. There's 100,000 penguins on the island at time t. The birth rate for the penguins on the island is modeled by this b of t equals 1,000 e to the 0.06 t, and the death rate is d of t equals 250 e to the 0.1 t penguins per year.
That's overpopulation.
So we do B minus T.
Is there poaching?
B minus d, yeah, good job. Yep. Right, so the rate of change, right, it's going to be the number of penguins we add in minus the number we remove. All right, I had a professor in college who did problems like this. That was her research. I think it was like butterfly populations though or something.
What does penguin taste
All right.
good?
I wonder if penguin tastes good.
Oh, we taste like chicken, yeah.
Probably does.
Chicken's good, so.
Flightless bird. Dude, imagine being a bird you just can't.
I mean, if you're an ostrich, you kind of.
All right, so that's the rate of change. Are we confused on that?
That would be like a deer.
Wait,
We kind of just used like our intuition of reality for that one.
where did you get like the 250
The D of T, the line right above it.
The what?
The line right above, if you read the problem.
Oh, I see.
Yeah.
Deer, ostrich. Oh, no, that's
Dude,
not.
All right, example 3.
So light.
Oh, no.
Let's finish this one and go to lunch. So a certain grocery store opens. It's got 50 pounds of bananas on a display table. And the bananas are removed at this rate. The store employees add bananas at this rate. So what's the rate of change going to be? What's F? Actually, no, they actually just want F prime. How would we find F prime of 7? It's a calculator problem. Yeah, so find the first derivative with your calculator and plug it in, okay? So let's start doing that.
I'm not looking at programs. You have to do this math in order to look at programs. Some of program application stuff.
All right, go to lunch. Come back at 45.
Are we gonna finish that problem?
Yeah, oh yeah, on the, we'll come back. I think we're all checked out.
Why?
What time are we coming back?
45. Yeah, 45, please, yes.
Wait, show Mr. Rushton the flash one.
Oh, this is very cool. This is not the right seat. I think my favorite app is this.
Again, it just has to work on
All right.
Buy the premium version, like 30 different apps.
So for this one, I'll give them another 1 minute.
Oh, they better be late. Oh, they better be late. Oh, they better be late.
Is there any?
Oh, we got 30 seconds. Even
Yeah, it's like the way I did the calculator yesterday. I'm gonna go back to 1984. Or grab.
This is mad impressive.
I know, I was like the second person.
Well, I can have that on the rest of the version.
It's like this. It's like the jumbotron at a sports game.
Dude. One time I was on the Jumbotron and they gave me a signed baseball. I was in a baseball game, they put me on the Jumbotron, they gave me a signed baseball every time.
Ooh, do something.
It's so cool.
Aren't you like live streaming the class on Twitch?
No.
Are you not subscribed?
We're recording on that computer though.
Do you have a text-to-speech on, please? I'm trying to
Texas Beach.
text-to-speech.
Closed caption, TTS.
Is that what that is?
If I donate something, it says that.
No, when you post it to YouTube, can you enable closed captions, please?
Sure.
Because
You're hard of hearing. A little hard of hearing.
yeah.
All right. All right. So let's do this next problem here in the notes. Okay. So they just asked us what f prime of 7 is. They asked us f prime, and they want us to interpret it. Right. So it's not too difficult to find f prime. It's not too difficult to find f prime of 7 using your calculator. Okay. We don't want to use it. We don't want to do it by hand here because we want to save time and do it on our calculator. Okay. So I'll show you guys how to do it on my calculator again. You can't see it. There.
Oh, I was in the middle of it.
Just keep coming back to different people.
All right. Y equals, okay? What is that y1 function? What is it? 10 plus 0.8t.
Yeah.
Sine of t cubed over 100. So it'd be x cubed.
Okay, you should not do the work.
That's it. Okay, cool. And then we want to make sure our calculator is on radian mode, so hit the mode button. Make sure it's on radian. Make sure it's on flow. Alright, so we want to take the derivative, so we want to take the
Did you
wanna
type
take-
in the second function?
I didn't, because they just want f prime, right?
Okay.
Right, so I want the derivative of y1 and x equals 7.
Whoa.
Oh.
Whoa.
Oh, there you
X equals
What's
7.
your iPad don't look
How do I put in the?
Alright, so we hit math. We got an inderiv. X. So we put y1 in there, right? So we hit the vars button. Scroll over to y vars, select function. Okay, and then we wanted an x equals 7. Just gonna spit it right out. Negative 8.11, negative 8.2, negative 8.2. Okay.
Is this bananas?
Okay, so then using correct units, explain the meaning of f prime of 7, okay? So we gotta think about this, right? We gotta think about this. Okay. Right, so f of t is the rate at which customers remove bananas from the display table. Okay, it's measured in pounds per hour. Okay? So f prime of 7, right? That negative 8.2, that's a slope, right? That's a slope. Okay. So let's think about this. That means customers. That's a slope of the rate of change. So the rate at which, right, customers remove bananas, kind of a weird example. It's also a weird function. Anyway, sorry. It decreases, right? Decreases by 8.2 pounds per hour. Okay, so let's think about this. F prime. What are the units of slope? What are the units of slope? It's going to be pounds per hour. Right? Right, change in bananas over change in time, right? Change in pounds of bananas over change in time, okay? F is, like the units of F are pounds per hour, okay? When we do F prime, it's going to be change in F, so change in our pounds per hour per unit time, per hour.
So you do a derivative, you do per hour.
That's why acceleration is meters per second squared.
Per second.
Yeah. Okay.
So can we do pounds per hour squared?
Yeah, sure. You can do pounds per hour squared. All right. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for any answer, okay? So it's going to be increasing if what is the case?
G of 2 is
If the rate at which they're replaced is greater than the rate at which they're taken away, then it's going to be increasing, okay? If the rate at which customers take them off the shelves is greater than the rate at which the store workers can replace them, it's going to be decreasing, right? It's kind of like toilet paper during the pandemic, okay? All right, so we got to look at f of 5. We got to evaluate f of 5 and g of 5, okay? So you do that with your calculator, okay? Okay. Okay. Where's my calculator? So now I am going to put g in my calculator.
So now we're putting G.
What's that?
Is it F prime of 5?
No. You got to read the problem carefully. F is the rate. F is the rate and G is the rate. So just because there's no prime there doesn't mean we're not dealing with like a rate. Okay. All right, so I got both my functions plugged in, okay? I want to get f of 5, okay? So make it ungraph the blue. So I want to turn that graph off.
Do you just press enter?
Yeah, when you hover over the equal sign, hit graph. So that's the rate. This just makes no physical. This problem's like hilarious. All right, so trace 5, enter. We doing okay? So 13.796.
Yeah, I think either way to do it.
What?
What do you just do there?
If you just do y1 times the number, gets you the number.
Oh, really? That doesn't interpret it as, oh, sick. Okay, cool.
Wait, what are your graphing?
Wait, can I see it?
That looks like my heartbeat.
Mine just doesn't, mine looks like,
Oh, that was,
Mine doesn't touch the
Is mine wrong?
x-axis.
Did I do something wrong?
no,
Did I put it in wrong?
I got the same value.
Okay, so now I want G of 5, so I'm going to turn off F, turn on G.
Wait, mine does not look like that.
Okay, and then I'm going to trace 5, enter. I'm going to write that answer down. So this is 11.533.
Change the way you have it.
533? Yeah, no.
Okay, so see if you have the same window as I do. Do you have the same window as I?
But when I did, what's your window? When I did 100 to
It might not be, the window shouldn't affect the actual answer yet.
Wait, Mr. Roscoe.
Yeah.
So my graph looks like this, but when I pressed like y equals 5, it's the same number as yours.
That's fine. It's probably a different window.
Yeah.
All that matters.
Yeah, I got it now.
Make sure you're in the same mode. Max print normal flow rating function 6. Sequential.
And then how do you find the 5?
You hit trace.
Oh, I see.
Trace.
Watch him come back and be like, retreat sucked. Because, you know, they give you guns and stuff.
And are we what is this
Some of
one?
the jokes need to really do
Find
that.
the derivative or no?
This is that's f of 5 and g of 5. We've got f of 5 and g of 5, right? So the case here is that f of 5 is greater than g of 5. So let's justify our answer then, okay? Since the rate at which customers remove bananas is greater than the rate at which they're replaced. I'll just call them patrons. Right, then the number of bananas is
In Spanish.
I don't know how to say rate, I don't know how to say patrons, I don't know how to say replaced.
Yeah. Okay, how do you say that in Spanish? They won't.
Does every college require a language?
No.
I need to check.
Porque rap, de
Yeah,
canciones,
languages in college are really hard.
de cada plátanos,
You're on
es más que
essays.
rato.
Senor Morris got me to test out. Georgetown was
de
nice.
abajo.
Okay, are we having trouble understanding the reasoning here? So I think a big takeaway from this one is if they give you f of 5 and g of 5, f of t and g of t, just because there's no prime here doesn't mean that it's not like a rate. So that's, you gotta read the context of the problem. Right? They say f is the rate at which bananas are removed. G is the rate at which they are added. Tree was terrible. Tree was horrible. Alright, so C, and then I think we're actually done with, I'm sorry, I didn't print off the 4.3 homework. I didn't think we,
I'll work on that.
We don't need it. We're still working on the 4.2.
okay, sounds good. Alright, we can move on to 4.4, related rates. Intro to related rates. I've been waiting for this one all year.
I think we should get homework time instead.
What's that?
I think we should get homework time instead. I'm good with related rates.
You're good with related rates?
You are related
Related
rates. Thank you.
So related rates are definitely the hardest part of differential calculus.
Nice.
Ready.
Take those like really hard word problems from Mrs. Ford's class and put calculus in them and you get related rates.
Okay.
Like all the problems were like, it's like there's a cone of water and it's like filling up,
At some point.
you know? Anyway,
We're done.
there we go.
Right now.
So next application of the derivatives
I got that.
is going to focus on two or more rates that are simultaneously changing. So related rates, that are rates which are related. So let's conceptualize how the two rates can exist and be related to each other, okay? So, yeah, suppose water is poured at a steady rate into these containers. Sketch the graph of the height of the water versus time. Okay, so water is poured in at a constant rate, right? So let's look at this rectangular prism here, right? Right, we take this rectangular tank and we pour in water at a constant rate. If we pour in water at a constant rate, not a terrible artist. If we pour in water at a constant rate, the height's going to increase at a constant rate. I think it's pretty intuitive, right? Right, that's because the surface, that's because the area of a cross section is constant in a rectangular tank. Right? height of the water is going to increase at a constant rate as time goes by. Okay. If we look at this one, what's going to happen? So it's going to start out, right? It's going to start out increasing at a constant rate, right? Then what's going to happen to the rate?
Speed up.
It's going to speed up, right? Why does it speed up? Right, it takes less water. Once we get to this point, once we get to the base of like the T, once we get to this point, it takes less water to actually increase the height, right? So if the actual rate at which it's being poured in stays the same, then the height's going to increase faster, okay?
Why does it cut down deep?
All right, what about this one?
Constant.
This one, right, it's going to go up at a constant rate, and then when we get to the bottom of that I, is it the rate going to increase, decrease?
Increase.
It's going to increase
There's a
suddenly,
constant and then decrease.
and then it goes back to that old rate.
This don't seem that bad.
No.
I said this doesn't seem that bad.
Well, yeah, it's just the conceptual background.
I don't know.
Yeah, I'm gonna say.
We haven't
This
tested
one-
this out.
The rate decreases for this one, right? So it's going up, and then it hits
Constant.
it's the bigger.
And then very slow.
Yeah, slower. All right, so the two rates that are related here are the height of the water versus the volume of water, right? And we relate them via the shape of the object which is getting filled up. Okay. We relate them via the shape of the object which is being filled. Okay. Little intro to related rates. Okay. Okay, I feel like you guys actually were pretty confused on the homework, the 4.2s. So do you guys just want to talk about some of those?
Yes,
homework
please.
time.
Okay.
I have some questions.
I feel like this is going to help us more. Now that we got through everything I wanted to get through. Sorry about the homework. Let's talk about the homework. All right. So do you guys want to do like the sign chart for velocity for this one? Okay. No, you don't. I don't know.
Wait, can we just do the problem together?
Yeah. So how would we?
Do the second one?
Yeah. How would we start doing the sign chart for V? How do we find V again? We should all know this. Yeah. So V of t equals s prime of t. Here it's going to be negative 3t squared plus 18t minus 24. And so we have our little number line for velocity. What are all the points we plot? So what do we plot? Well, like in general, the zeros in the vertical asymptotes and the zeros here are 2 and 4. You can find that by factoring or use the quadratic formula.
Could we factor this one or no?
I hate factoring quadratics, especially ones that, well, I don't mind factoring them. I hate it when the lead coefficient is not 1, especially when it's a negative. So I would just recommend using quadratic formula. So t, what's that? Oh, you can just divide that?
Yeah,
Take a negative 3 and make it.
Yeah, that's true.
It's just-
Or you can just use the quadratic formula.
I forgot.
So t equals plus or minus, or t equals the opposite of 18, plus or minus. If you get a calculator, square root of. If you don't get a calculator, you want to factor it. So plus or minus 18 squared minus 4 times negative 3 times negative 24. All over 2 times negative 3, which simplifies to 2 and 4. Okay, 2 and 4, okay, and then, all right, so for the sign chart, right, what do we want to do now? Dinara, what do we want to do now?
We're plugging a number between 0 and 2.
0 and 2, yeah.
You plug it into your derived equation or your
Into V, so this is, look at the function that's next to the line. Yeah. Plug it into V, okay? So if we plug in a number to the, like 1, we'll get a positive. If we plug in like 3 in the middle, we'll get a negative. We plug in,
Wait, so I'm sorry, you said plug into the original? Or did you
plug into V.
Oh, into B. Okay, so you plug in, so 0 0 to 2 is 1, so you put a 1 of positive.
Mm-hmm. And it's also a parabola, so you can like parabola that opens down. Sorry, did I do this backwards? I did.
Yeah.
It should be negative, positive, negative.
Yes.
Yeah. With parabolas, it's easy to tell, like this is a parabola opening down, so you know it'll be negative and positive and negative, right? Because the graph's going to look like that. You feeling okay about that? Then acceleration, what do I do to find the acceleration? S double prime. So now it's going to be negative 6t plus 18. The only zero there is 3, right?
Yeah.
Are there any asymptotes?
No.
Yep. To the left of 3, I am, if I plug in 2, I get a positive number. If I plug in 4, I get a negative number. Okay, so it's the sign charts. Motion. So I'm going to plug in, so I'm going to look, what's motion? So motion refers to whether I'm speeding up or slowing down, right? So what two functions am I interested in here? V and A, right? It's speeding up if V and A have the same sign. It's slowing down if they have different signs. I don't even care about position. I don't care.
Wait, so then you, I'm sorry, for A of T, you find the zeros of that, right?
I'm sorry, what?
Sorry. A of T, you find the zeros of the second derivative function, right?
Zeros in vertical asymptotes. There are no vertical asymptotes here. All right, so we want to combine. So on this graph, we're going to put a t. We're going to plot all of our zeros and vertical asymptotes of our v and t function or v and a functions. Okay, so basically what you do is, if there's a point on one of these lines, you put it on this third line. Okay. Okay about that?
I'm sorry, can you repeat yourself?
So if there's a point on either our V or our A, we want to copy that point down to this motion timeline. Okay. All right, and then we just want to analyze the signs, right? So from 0 to 2, what's going on? I want to know whether I'm speeding up or slowing down. How do I figure that out? I look at the sign of V from 0 to 2, that's negative. From 0 to 2, the sign of A is positive. So is it speeding up or slowing down? Slowing down. From 2 to 3, the sign of V is positive. The sign of A is positive. So it's speeding up. Speeding up. From 3 to 4, okay, from 3 to 4, the sign of velocity is positive. The sign of acceleration is negative, so it's slowing down.
Wait, why is it slowing down?
Because velocity has a positive sign and acceleration has a negative sign. The signs are different, so it's slowing down.
Oh, okay.
Yeah, and then 4 onward, they're both negative, so it's speeding up. We feeling okay?
Yeah.
All right, what else do we want to go over? 3 minutes left of class.
How do you draw the position thing?
Yeah, that's what I'm confused.
Like-
How you do the last line?
Oh, that thing. I'm so sorry. I totally misinterpreted what you were asking.
That's okay.
I'm sorry. Okay, yeah. So for these, I don't know where like the 20 and stuff came from. I really
They had
don't.
a lot of numbers.
Yeah. So it's going to be moving. Let's think about this. It's going to be going in the negative direction, right?
Yeah.
How do you?
Velocity starts out negative, so it's moving
So wherever it starts.
to the left. Yeah. Yeah, so I'd have to like write these backward. What does the answer key say? Did I post the answer key to this?
Yeah, but I forgot what it said.
Okay.
Bless you.
Yeah, I was gonna say it has to. It starts out.
Why, where did you, 9?
Where's position? Okay. Let me ask Mr. Shadio, because I don't know how important the position line is. So it starts at 1 here, okay? It starts at 1 because if you plug in t equals 0 into s, you'll get 1. You'll get 1. And then it starts out moving to the left for a while. Yeah, I mean, I'm kind of thrown off by that as well. It's one of those things I'm thrown off by it. I've never seen that. I don't remember seeing it a lot like when I took the course, but I'll ask Mr. Shaddy about it and get back to you guys. 'Cause I'm not sure. What else do we want to talk about here? The main thing I want you guys to worry about is like knowing how to make a sign chart and like knowing when stuff's speeding up or slowing down or.
Is this called the sign chart, this whole thing?
Yeah. Sign charts are really important. So these are very important. What else do we want to talk about? 45 caliber bullet. This is a good one, number 3.
This one.
What did we do for this? What would we do for this one? We did almost an identical one. What's the password? Okay. What will we do? So, right, the trajectory. This. What does this function look like? This is t, and this is the height s of t. What does this function look like? Either of these. It's a upside down parabola, right? Right. So what do we want to know? We want to know how long it took to do what? To hit the ground, right? What's the point here at which it hits the ground? On this graph, which point here corresponds to hitting the ground?
0.
This second 0 here, right? Right, starts from the ground, right? So we want to know when t is, this root t. So we'd find the roots of both functions, right? This is a little conceptual understanding. Phineas and Ferb.
I have a question about number 6.
Number 6.
Wait, what was the answer to 3?
That was just so I was going over it conceptually.
Can you do it?
You just find the zeros of each parabola. So there's 2 parabolas here. You find the second 0.
And do we do this with our calculator? Or
Yeah, you can use your calculator. Right. So you set s equal to 0. Right. Horizontal axis is when s equals 0. So you set. Right, so for Earth, what's the Earth one? You'd be 0 equals 832 t minus 16t squared. Solve for t, so that becomes t times 832 minus 16t. Set this equal to 0, that'll be your solution. Right, just like in algebra 1.
so we don't use our calculator?
I mean, you'd have to do 832 divided by 16, so I'd say use a calculator. Any other questions?
Sorry, same thing with the moon.
Yeah, same thing with the moon, just a different equation. Top depth of the Eiffel Tower.
Can we go over 14?
What's that?
14?
14?
Like 2 minutes left?
Yeah.
I just want to know. You're right, they're on 2 minutes left. It's not worth it.
Tom Petty, it's not worth it.
Just
Tom Petty's a skydiver. When he free falls, his downward velocity is a function. Here we go. Here's another good example. Okay, they give you the velocity. There's not a prime symbol here, so you really need to make sure you read the text and the problem and interpret in context. Okay, this is a rate, right?
You said another one? What's the other one?
The banana one.
Oh.
Yeah. Okay, so this is just plugging stuff into our calculator. This first one.
When you plug this in, you graph it, and then you type in 30 into like y.
Yeah. Trace 30, enter. Yeah.
Okay.
A is terminal velocity. The limit of his velocity as t goes to infinity, right? That's his final v. Right? So his drag is going to slow him down. Gravity speeds him up. Drag is proportional to his speed. So as his speed increases, drag gets so great that it starts to actually prevent him from speeding up anymore. That's terminal velocity. Nick. Yeah. The terminal velocity is going to be based on like the surface area to volume ratio, mass to surface area ratio. That's why ants can't like die from a free fall. They're using what's the perk in Call of Duty? Lightweight Pro. Okay. They have Lightweight Pro. What's it? I did. Yeah. Which one? Player? This one? You applying to Hopkins?
No. I just was out there. Not applying to Jack I like Hopkins, but they were really focused on research. I didn't really want to do research. I don't want to go into research.
Don't go to Hopkins.
Yeah. You like my what? Roll? Cool. Oh, that's right. Yeah, it's actually really bad.
I like the more like liberal artsy schools just because the people I think are funnier. I think the people are more creative.
Yeah, Mr. Russia. Postcards I get from her too. Like the postcards I get from liberal arts schools are funny.
Yeah.
But the ones I get from
Like STEM schools.
yeah,
it's
that's just like
we
boring.
stuff.
Exactly.
Could we all get 10 points if we get students for that?
Like a homework.
Yeah, like literally just 10 points participation for
The
the
homework won't really do
Are you guys feeling okay about this stuff?
Yeah, so far.
Okay.
It'll help me a little bit.
Okay.
Wait, so what do you do from here?
You're just finding the zeros of it. So you remember how to find the zeros of a parabola. You set each of your factors equal to 0.
Oh,
You want the
and then
zero that you don't want the trivial 0. You want the non-trivial 0.
Okay. Thank you.
Yeah. Me too.
Did we ever collect the 2 participation ones? No.
Discovering something that doesn't exist, or giving a mommy a shower. Okay. Phineas and Ferb.